Do you know all the circuit components that you should know for GCSE Physics, Combined Science or IGCSE Physics? Well, we're going to have a look at the symbols and what all the components do, as well as the IV graphs that you need to know. This is a resistor. We can make it into a variable resistor by putting an arrow through it. We can make it into a light-dependent resistor by putting two small arrows coming into it to represent the light. You may see it with or without a circle around it. We could also have a temperature-dependent resistor, what we call a thermistor. And we can make it into a thermistor by adding a line shaped like a hockey stick. The resistance of an LDR decreases as the light intensity increases. The resistance of a thermistor, at least all the ones you'll come across, decreases as temperature increases. A normal resistor is known as an ohmic conductor. That means it obeys Ohm's law. Ohm's law tells us that the current through the resistor is proportional to the voltage across it at a constant temperature. What that means is that if we plot a graph of current against voltage for a resistor or an ohmic conductor, we get a straight line. Now, we sometimes call a current voltage graph an IV graph. We can get a set of results to plot this graph by building this circuit. The battery and the variable resistor are there to control the potential difference or the voltage across the component we're measuring. Instead of using a battery and a variable resistor, we could use a variable power supply. Notice the variable power supply has an arrow through it to show that it's variable. A wire is also an ohmic conductor, so if we did the same experiment with a piece of wire, we'd get the same shaped graph. A filament lamp, that's not an ohmic conductor. So if we build a circuit to take the results for a filament lamp, we get a very different set of results. Here's the shape of graph we get. If we were asked to describe the relationship shown in the graph, which is a pretty common type of exam question, then we would have to first start off with the most obvious thing, and students do often miss this out. The most obvious thing is that as voltage increases, the current increases. The second statement we need to make is a bit more complicated. It's about the shape of the graph. Now, I would probably say that as the voltage increases, the rate of increase of the current decreases. I guess that's perhaps a little bit of a mouthful. Really, what I'm trying to say is it's a non-linear relationship, but that won't always get you the second mark. Just saying non-linear. Why is the IV graph for a filament lamp shaped like this? Well, that's because as we increase the potential difference, the current increases, and that increases the temperature within the filament. Once the temperature goes up, the ions inside the filament, they move around a lot more, the molecules move around a lot more, so it's harder for the electrons to get through the filament, so its resistance increases. Before we look at diodes, please take a moment to subscribe to this channel and even like this video. That way I can keep producing these free resources and all the resources you find on my website for free as well, videoplatoacademy.com. There you'll also find out how to access my personal tutoring and the revision courses that I offer live with me. A diode is a component that only allows current to flow through it in one direction. If you look at the symbol for a diode, you can see there's an arrow pointing in the direction that current can flow, and then a line that blocks the current if it tries to come from the other way. You may see that symbol with a circle round it as well. You may have heard of an LED, a light emitting diode. That means when the current's flowing through it and it's on, it gives off a light. And we can represent that light with two little arrows coming away from the symbol. To build a circuit to get the results we need for an IV graph for a diode, we need to add the diode and a resistor to protect the diode. Diodes can be a bit delicate and too high a current will stop them working. We can see from the IV graph for a diode, it takes a small amount of voltage to actually activate it, to turn it on. Typically around about 0.7 volts. Don't worry, you don't need to remember or know that. There's a very important difference though between the IV graph for a diode and the IV graphs for an ohmic conductor or a filament lamp. If we take the ohmic conductor and the filament lamp and we reverse the components in the circuit or reverse the battery so that they're the opposite way round, we still get exactly the same shape graph. A lamp behaves exactly the same, whichever way it's connected. So does a resistor or a piece of wire. A diode doesn't. Remember, the diode only lets the current through in one way. If a component like a diode behaves differently depending which way round it's connected, then we say it has a forwards bias direction and a reverse bias direction. So the diode works in its forwards bias direction, but doesn't work in its reverse bias direction. If you've got any questions or any comments, put them below and I'd love to read them and respond to you. For now, watch this.